In this question, a kettle is heating water, 500 grams of water, from 20 degrees Celsius to 100 degrees Celsius. And we're asked to calculate how much thermal energy does the kettle transfer to the water. The big clue for this question is that they give us the specific heat capacity of water as 4,200 joules per kilogram per degree Celsius. So let's dive into this calculation using list, equation, solve, and state. So to begin with, let's make a data list. What do we know? Well, we know that C, the specific heat capacity of water, is 4,200 joules per kilogram degree Celsius. And that's telling us how much energy you need to put into 1 kilogram of water to raise its temperature by 1 degree Celsius. Then we're told that the mass is 500 grams. And they've given us the temperatures at the beginning and at the end. So the change in temperature is the end temperature, 100 degrees C, minus the starting temperature. So we have a temperature rise of plus 80 degrees C. And we are looking for the thermal energy that is transferred to the water. So that's going to be our question mark in joules. So it's now tempting to rush on and put all these numbers into the equation, but it's a really good idea to just hold fire once you've done your data list and check that we've got all the units in their standard format. So joules, kilograms, degrees Celsius, yes, that's okay. But look, we've got grams here, so that's not a standard unit in physics. We need to convert that into kilograms. So there are 1,000 grams in each kilogram, so that would be 0.5 kilograms dividing by 1,000. Now we're ready to go on and write down the equation which links all of these quantities together. It's the specific heat capacity equation. E is mass times by the specific heat capacity times by the change in temperature. Let's put the numbers in, and we get 0.5 multiplied by 4,200 multiplied by 80, and if we put those into the calculator, we get 168,000. 168,000. State the answer with the correct unit. So E equals 168,000 joules. We can always check our data list to make sure that it matches. Yes, it does. And we might want to put that into kilojoules, which is a little bit easier to read. 168 kilojoules. So that's the energy that the kettle has transferred to the water to make its temperature rise from 20 to 100 degrees Celsius. But bear in mind that we have assumed that all of the electrical energy of the kettle, if it's an electric kettle, has gone into the water. Now in practice that's not the case, because we would have lost some energy due to electromagnetic radiation, infrared radiation, and maybe some gas has escaped. That would be convection. And so we'd probably find that the kettle has actually provided more energy than this 168,000 joules, because we've lost some in the process.